Efficient IT operations depend upon the ability to execute business processes accurately, consistently, and with minimal manual intervention. Modern enterprises rely on job scheduling, production process automation, and system interfaces to support high-volume transaction processing, enterprise application integration, and continuous service delivery. These operational capabilities reduce human error, improve resource utilization, and enable organizations to maintain business continuity while supporting increasingly complex digital ecosystems. Within the CISA framework, IS auditors evaluate whether automated production processes and system interfaces operate securely, reliably, and under appropriate governance controls. Job scheduling and production process automation. Job scheduling is the process of planning, sequencing, and executing automated processing tasks according to predefined schedules, dependencies, or triggering events. Production jobs may include database updates, payroll processing, report generation, batch transactions, file transfers, backups, system maintenance, and application integrations. Automation allows organizations to perform repetitive operational activities consistently without continuous human intervention, thereby improving efficiency while reducing operational risk. Automated scheduling systems coordinate thousands of daily processing activities across servers, databases, storage systems, cloud platforms, and enterprise applications. Typical scheduled production activities include batch transaction processing, end-of-day financial processing, data warehouse updates, backup and archival operations, log rotation and maintenance, patch deployment, report generation, data synchronization, file transfers between business partners. Production scheduling systems execute these tasks according to defined calendars, event triggers, or interdependent workflows, ensuring that prerequisite jobs complete successfully before dependent activities begin. Automation introduces significant governance benefits, including standardized execution, reduced operator error, improved auditability, and optimized utilization of computing resources. However, it also introduces operational risks if scheduling parameters, dependencies, or automated scripts are improperly configured. Effective production automation therefore requires documented scheduling procedures, formal change management, segregation of duties, job dependency validation, automated monitoring, exception reporting, error recovery procedures, restart and rollback capabilities, comprehensive logging and audit trails. Production automation should also incorporate monitoring mechanisms capable of detecting abnormal job termination, excessive execution time, missing input files, duplicate processing, or resource exhaustion. Modern organizations increasingly integrate orchestration platforms that coordinate activities across hybrid cloud and on-premises environments, enabling automated provisioning, workload balancing, and service execution. Automation technologies such as infrastructure as code, IAC, robotic process automation, RPA, and workflow orchestration further reduce manual operational activities while increasing consistency and scalability. From an IS audit perspective, auditors assess whether production jobs are formally authorized, appropriately documented, adequately monitored, and protected against unauthorized modification. Audit procedures also verify that production scheduling systems maintain complete execution logs, preserve processing integrity, and support timely recovery from operational failures. System interfaces. Modern enterprise applications rarely operate independently. Instead, organizations depend upon system interfaces that exchange information among internal applications, cloud platforms, external business partners, financial institutions, government agencies, and customer-facing services. System interfaces enable business process integration while eliminating redundant data entry and improving operational efficiency. A system interface is a communication mechanism through which two or more independent systems exchange data automatically. Interfaces may transfer information in real-time, near real-time, or batch mode depending upon business requirements. Common interface technologies include application programming interfaces, APIs, web services, message queues, file transfer protocols, database replication middleware platforms, enterprise service buses, ESB, event-driven messaging systems. Technical requirements for new information systems should define specific data layouts for interfaces, middleware compatibility, language support, client platform requirements, and integration mechanisms to ensure that new systems operate harmoniously within the existing enterprise architecture. Well-designed interface specifications reduce implementation complexity and facilitate interoperability across heterogeneous environments. Interfaces process significant volumes of business-critical information, making data integrity one of the primary control objectives. Organizations should implement validation controls that verify data completeness, data accuracy, record sequencing format, validation, duplicate detection, error handling, transaction reconciliation, exception reporting. These controls reduce the likelihood of corrupted, incomplete, or unauthorized information entering downstream systems. Security is equally important because interfaces frequently transmit sensitive financial, operational, or personal information across internal and external networks. Organizations should implement strong authentication, encryption, access control, digital certificates, secure communication protocols, and logging mechanisms to protect interface communications from interception or manipulation. Modern enterprise environments increasingly utilize secure protocols such as HTTPS, Secure Shell, SSH, and encrypted API communications to protect system-to-system transactions. Auditors also evaluate interface resilience by reviewing retry mechanisms, queue management, transaction acknowledgements, timeout handling, reconciliation reports, and recovery procedures following communication failures. Effective interface monitoring enables operations personnel to identify failed transmissions quickly and restore processing before business operations are significantly affected. Documentation represents another critical governance requirement. System documentation should describe internal and external data flows, interfaces, processing logic, configuration management procedures, security controls, and disaster recovery considerations, enabling developers, operators, auditors, and support personnel to understand and maintain integrated business systems effectively. For CISA professionals, understanding job scheduling and production process automation together with system interfaces is essential for evaluating whether enterprise operations are reliable, efficient, secure, and resilient. Strong governance over automated processing and integrated information flows enhances operational continuity, reduces processing errors, supports regulatory compliance, and ensures that interconnected information systems consistently deliver accurate and timely business services.